For this video, we're going to talk about how to find the focus in the directrix. Remember that if you have a parabola, the definition of a parabola is the set of all points that are equidistant from a given point called the focus, which is always going to be inside of the parabola, and a given line that is called the directrix, which will always be outside of the parabola. And the distance from the focus to the vertex, which is the maximum or minimum point, is always the same as the distance from the vertex to the directrix. And to find that distance, all you have to do is measure or determine how far this is. We call this distance P, and it's going to be the same as this distance. So the distance from the vertex to the directrix is P, and the distance from the vertex to the focus is P. P is what we know as the focal length. So the distance from the focus to the vertex, or the distance from the vertex to the directrix, is called the focal length. Now, in order to determine this, we're going to go back to the problems we did earlier and figure out which way the parabola opens, first of all. We have a y equals equation, and we've got a negative a value. So this parabola is going to open downwards, which means that its focus is going to be below the vertex, and the directrix is going to be above. So I like to write those two things down. Focus, you can write F, is below, and directrix, D, is above. Now if I'm talking about below and above, I'm talking about some up and down movement, which is related to the y-axis. So I'm going to find the y value of the vertex, and to go below, I'm going to subtract P, which is the distance from the vertex to the focus. To move above, I'm going to take the y value, and I'm going to add P, which is the distance from the vertex to the directrix. Now, to determine what P is, we use a formula. And the formula is pretty easy. It's just P equals 1 over 4 times A. But I can also write that as A equals 1 over 4 times P. Either one of those that's easier for you to use, you're welcome to use. I'm going to use the second formula, A equals 1 over 4P, because I think that's going to be a little bit easier. And just to be precise, we're doing the absolute value of A. So I'm going to do the absolute value of negative 1/32 equals 1 over 4 times P. Now, the absolute value is just going to make the negative 1/32 positive, and that equals 1 over 4P. Now, to solve this equation, we do something called cross multiply. We multiply the bottom of one fraction times the top of the other one, and then we multiply in the opposite direction. So I get 32 equals 4P, and if you do some quick division, you'll see that P equals 8. So I know what to use for my P value. That's going to be 8 in both of these problems. So the only other question is, what's the y value for the vertex? To find the vertex, we look at our equation. And whatever is added to or subtracted from the x in parentheses is going to be your x value for your vertex. Well, there's nothing added or subtracted to the x inside the parentheses, so we got 0 for the x value. And whatever is added or subtracted after the squared, that's going to be our y value, but there's nothing there either. So the y value is 0 as well. So my vertex is at 0, 0. So for my y value of my vertex, I'm going to substitute 0 in both of these equations. And like we said before, our p value is 8. So I'm going to do minus 8 and plus 8. Now a directrix is a line, and in this case, the directrix is a horizontal line. So we're going to use this y here again and say y equals 0 plus 8 is 8. That's our equation for our directrix. For the focus, we have an ordered pair. And the focus is always going to be directly above or below or left or right of the vertex. In this case, it's directly below, which means it's going to have the same x value. And the only thing that changes is the y value. And it changes to 0 minus 8 or negative 8. So this is my focus, this is my directrix, and I've solved this problem. In the next problem, like we did on the previous one, make sure you determine which way the parabola opens first. This is an x equals problem, so it could open left or right, but since the a value is 1/3 or positive, it's going to open towards the right, which means that my focus is going to be to the right of the vertex. Focus is right, and my directrix is going to be to the left of the vertex. So if I'm moving right and left, I'm talking about x values. And if I move to the right, I'm going to add. If I move to the left, I'm going to subtract. And we always add or subtract p because that's the focal length, the distance from the vertex to the focus or from the vertex to the directrix. So now I've got to determine what my vertex is and what my p-value is. In this problem, once again, I don't have anything added to or subtracted from the y inside parentheses. So in this case, the y value for the vertex is going to be 0. And since I don't have anything added to or subtracted after the squared, my x value is going to be 0 as well. So my vertex is at 0, 0. And the x value of the vertex is 0. Now I just need to solve for p. Remember, our equation for p is p equals 1 over 4a, or a equals 1 over 4p. And don't forget to take the absolute value. In this problem, the absolute value of a positive number is still a positive number. So I get 1/3 equals 1 over 4 times p. And when I cross multiply, I get 3 and 4 times p. And then when I divide, I get p equals 3/4. So now all I have to do is add 3/4 to x or subtract 3/4 from x. And since we're talking about adding and subtracting to the x value and the focus is a point, my x value is going to change from 0 to 0 plus 3/4. But my y value is not going to change because I didn't move up or down. I only moved to the right. For my directrix, this time it's a vertical line. Vertical lines are x equals. So in this case, I have x equals 0 minus 3/4, which is negative 3/4. So this is the equation for my directrix. This is the equation for my focus, and I'm done with that problem. Now in this problem, we have to get the unsquared variable alone first. So I've got to subtract x squared from both sides, and that gives me negative y equals negative x squared plus 3. And then, to finish getting the y alone, I've got to divide both sides by negative 1, because remember, this is a coefficient of negative 1. So I get y equals positive x squared minus 3. So now I can determine which way this parabola opens. In this case, the parabola opens in the same direction as the y-axis, but since the y-axis goes two ways, we need to look at the a value, which is in front of the x squared. In this case, it's a positive 1. So my parabola opens up, which means it could look something like this, with the focus above the vertex and the directrix below. So if the focus is above, that means we're going to take the y and we're going to add the p-value to move up. If the directrix is below, we're going to take the y value of the vertex and subtract p to move down. P, remember, is the focal length. So the distance from the vertex to the focus or from the vertex to the directrix. So I have to figure out what y is. In this situation, the vertex is going to be 0 for the x value because there's nothing in parentheses with the x. But it's going to be -3 for the y value because there's a minus sign after the squared. So we have -3 for the y value. And in this particular problem, I'm using the y's because I'm going to be moving above and below. So I'm going to have a -3 here and a -3 here when I substitute in for y. But I still don't know what p is. To find p, I can use either equation. I'm going to use a equals 1 over 4 times p. I know what a is. A in this case is just 1, the coefficient of the x squared. So 1 equals 1 over 4p. And I can cross multiply. If you want to make a fraction out of any number, you can divide it by 1. So I get 1 times 1 is 1, and 4p times 1 is 4p. Now I need to go back and divide both sides by 4. And you'll see that p equals 1/4. So now I can substitute 1/4 in for p in both of these little problems. Now, since a focus is a point, and I'm only moving the y value, my x value is going to stay 0 like it was in the vertex, and I'm just going to do -3 plus 1/4. Since those are opposite signs, I can subtract and keep the sign of the number with the greatest absolute value, and that's going to give me -2 and 3/4. And then for my directrix, since it's a line, and it's going to be a horizontal line here, I'm going to have a y equals, and -3 minus 1/4, since they have the same signs, I can add and keep the sign, -3 and 1/4. In this problem, we've got a little more going on. Compared to the others that we've done, we've never had a squared variable and an additional one, in this video at least. So in order to do this problem, we've got to do something called complete the square. When we complete the square, we've got to move this 9 to the other side because all I want on this side is the y squared, the 6y, and a blank. So I have 8x minus 9 equals y squared plus 6y plus a blank. Now what's going to have to go in the blank? Well, to figure that out, I take the b value, the 6, and divide it by 2. 6 divided by 2 is 3, and I square it. So I have 3 squared, which is 9. So that goes in the blank. But remember that if I add something to one side of the equation, I have to also add the same thing to the other side of the equation. So I'm going to add 9 to this side as well. And as you'll notice, I'll end up with 8x equals, I can go ahead and factor this to be y plus 3 squared. And now that I've completed the square, all I have to do is get the non-squared variable all by itself. So I'm going to divide both sides by 8. Now this is going to be a little bit weird, but I don't actually divide the stuff inside of the parentheses by 8. I actually divide the coefficient of the parentheses by 8. And since there's no number out there, I'm just dividing the coefficient of understood 1 by 8. So I get x equals 1/8 times y plus 3 squared. So now we can decide which way this parabola is going to open. Since it's x equals, it's going to open left or right like the x-axis, and since we have a positive a value, it's going to open to the right. So we got our parabola, our focus, and our directrix. Our focus is going to be to the right of the vertex, and our directrix is going to be to the left of the vertex. And since we're talking right and left, we're talking x's. When we move to the right, we're adding When we move to the left, we're subtracting. For our vertex itself, the vertex is going to have a y value that's the opposite of what's inside the parentheses. Remember, inside is always going to be opposite. The parentheses lie to you. So the y value for our vertex is going to be -3. The x value is going to be outside of the parentheses, just like the x over here. Notice there's nothing there. So the x value of the vertex is 0. So I'm going to be adding and subtracting to a 0 from the vertex. Now what's the p-value? To find the p-value we use the formula. A 1/8 equals 1 over 4 times p. So cross multiply, we get 4p equals 8 and p equals 2. So I'm going to add 2 and subtract 2. And now I just need to write my equation and my point. The focus is a point. And the x value changed to 2 from 0, and the y value stayed exactly the same. The directrix is a vertical line, x equals, and 0 minus 2 is -2. So our directrix is going to be x equals -2. And that is how you find the focus and the directrix of a parabola.